Similar triangles. Triangles can be similar by SSS, SAS, or AA. To use SSS, we would have to show that the three sides of one triangle are proportional to the three sides of the other triangle. Proportional implies that the three sides of one triangle can be multiplied by a number such that after the multiplication, we would produce the lengths of the sides of the other triangle. That's what proportional means. To be able to use SAS, I would have to show that two sides of one triangle are proportional to two sides of the other triangle, and the included angle, which is the angle between the two sides that were mentioned, are congruent, as we see here. To use AA, we would have to show that two angles of one triangle are congruent to two angles of the other triangle. For A, they're asking us to determine whether triangle ABE is similar to triangle DBC by SAS. So to make it easy for ourselves, we disconnect the two triangles and stand them next to each other. Now, notice the A part is taken care of. These two angles are congruent because they're vertical angles. Anytime you cross lines or segments, they form congruent vertical angles. Vertical angles are always congruent. So the A part is already taken care of. We just need to find out whether these two sides are proportional to these two sides. And how do we find that out? Well, you form a ratio between two corresponding sides. For example, 4/6 or 1/1.5. You go the other way, 6/4, 1.5/1. So let's take 4/6. That produces 2/3, okay? If this number, if I multiply this number times these two sides, and I produce these two numbers, then we say the sides are proportional between triangles. Now, how do I know? I want to multiply this one times the sides of the bigger triangle. The way you know is that if this is a number that is less than 1, that means you're going from the bigger to the smaller. So if you multiply 6 times 2/3, notice you get the 4. And if you multiply 1.5 times 2/3, the same number, I get the corresponding side for 1.5. So yes, the sides are proportional. Could you have done the 6/4? Sure. If you use a 6/4, 3/2, and this is a number bigger than 1, that means I'm going from the smaller to the bigger. So I multiply these two sides by this number, and it should produce these two sides. So notice 4 times 3/2 is 6. So 4 times 3/2 gave me this one. And 1 times 3/2 gives me this one. So yes, those two triangles are similar, the original triangles. These two triangles are similar by SAS. And that was part A. This is true. For B, we would like to determine whether triangle ABE is similar to triangle DBC by AA. And the answer is we cannot determine, because for AA, you would need two pairs of angles. We only know one pair to be equal. We don't have information about the rest. So because for lack of information, this does not hold. How about C? Can we say that triangle ABE is similar to triangle DBC by SSS? It does not hold, because to use SSS, you would have to know the lengths of the three sides of each of the triangles. But they only gave us these two sides for this triangle, these two sides for this triangle, and these sides are missing. So we don't have enough information for SSS. And D, the triangles are not similar. It's not true, since we demonstrated in A that they are in fact similar.